Good day. Welcome back to our YouTube channel. So if you're new here, welcome. My name is Stiffler and I'm the one that is going to be helping you today. So again, if you're new here, just please go and subscribe. Just rush to subscribe because that helps our channel a lot in terms of even the consistency. We'll keep on posting these videos that are going to help you. So on lesson 1 we did momentum, and we also did change in momentum and Newton's second law in terms of momentum. So in this second lesson, what you are to expect, we are going to cover the law of conservation of linear momentum, and we are going to cover elastic and inelastic collision like we said. On the first lesson, we focused on momentum, which we were only focusing on one object. So previously we were focusing on one object alone, right? So in this section, fourth, we are going to be focusing on a system. We are going to be focusing on a system. So one might ask, what is a system? So a system is a combination of two or more objects that are interacting with each other. A system is a combination of two or more objects that are interacting with each other. So already we discussed that this topic is more about collisions between two or more objects. So a system can be a small part of the universe. So this is a small part of the universe. So systems can include stuff like maybe two cars colliding, or it can include maybe when you are playing pool there. So when you are playing pool, balls can hit each other, balls can collide. So that is in short what you can call a system. So that's a system. But we are more interested in isolated systems. So what's an isolated system? So a system is a system that does not have a net external force. So a system that does not have a net external force. So it means that F net of external is equal to 0. So there are no effects of friction. That is a isolated system. So we are going to be talking about objects that are just colliding without any effects of external forces, right? That's what we are going to be talking about today, an isolated system. So sometimes they can ask you in the exam, what's an isolated system? And that's how you can answer that. So let's consider this collision in an isolated system. So we want to explore more on what happens when bodies collide. So when bodies collide in an isolated system, they are in contact with each other for a certain amount of time. So they will be in contact with each other for a certain amount of time, which that time it is the same. So they have the same time. So it means that the time of contact between this and that will be the same. So the time there will be equal to the time there. So also the other thing that happens is they exert forces on each other. They will exert forces on each other. But according to Newton's third law, which we studied in grade 11, we learned that if body A exerts a force on body B will simultaneously exert an equal force on body A but opposite in direction. So it means that since we are talking about this situation here where body A is going to the right and body B is going to the left, and you know that when we are dealing with momentum, we choose direction, right? So suppose, let's say our right is positive. So our right is positive, so it means that our left will be negative. So if that's the situation, if body A exerts a force on body B will simultaneously exert an equal force on body A but opposite in direction. So it means that the force that body A receives, so body A will receive a force that is going to the left, so that will be a negative force. Because body B is going that way, so it will exert a force on body A that is going that way. So it means that it will be negative force like that. And the force that is exerted on body B now, so body B, since it was going that way and body A is going there, it will exert a force on body B that is going to the right. So the force that is exerted on body B, it is to the right, and our right is positive like that. So this will only mean that the forces are equal but opposite in direction. So it means that the force that is exerted on this, it is a negative force net. And the force that is exerted on body A, it is a positive force net, like that, right? So what do we know about an object that underwent a collision? We know that the F net of that object is equal to the change in momentum over the change in time. So this is applying on body A. So this is happening on body A. So the F net will be that. And this is exactly happening on body B as well. So it means that body B is also going through the same thing, F net, change in momentum over change in time. But already we explained that our right is positive and our left is negative. So this will only mean that the force that body A is receiving, it is a negative F net. So we can multiply both sides by time. So F net multiplied by time will be equal to the change in momentum of this object. So also this same time is happening on body B. So body B, since it is positive, it is going to the right, the force that is exerted on that. So multiply by change in time will give us change in momentum, right? So now let's focus on body A for a while. So now on body A, what it will surely mean, it will be this F net or this negative F net multiplied by time will be equal to, we know that this is change in momentum, so this is momentum final of body A minus momentum initial of body A. So if we divide there by a negative, it will only mean that our F net change in time will be equivalent to negative momentum final of A minus momentum initial of A. So at the same time, our force net change in time will be equivalent, so we can multiply out the negative. So this is negative momentum final of A and then positive, so negative with a negative becomes positive momentum initial of body A. So this equation we can call it, so this is our equation 1. So the same thing that was happening on body B, we can also see that this F net change in time is the same as momentum final minus momentum initial of body B. So this is for body B, right? So this equation, let's call it equation 2. So we can see that we are having equation 1 there and we are having equation 2 there. Oh, that's a disaster. So this is initial of A. Since we said that the time is the same, so the time is equal and also the force is equal there. So it means that this side is equivalent to this side, so we can equate these equations. So from this equation, from body A, we can see that our negative momentum final of A plus momentum initial of A will be equivalent to this that we know about body B. We know that momentum final of B minus momentum initial of B. So now we can rearrange this formula in a sense that the positives that are one side and the negatives one side. So this will be the momentum initial of A plus, so this coming this side, it will be the momentum initial of B being the same as this taking the side, momentum final of body A plus momentum final of body B, which was already there. So when we are having such a situation now, we have something that we call the law of conservation of linear momentum. So the momentum is conserved there, right? So the momentum is conserved. So this is what we call the law of conservation of linear momentum. So it is the one that we are going to be talking about. So we can see that momentum initial of body A plus momentum initial of body B is equal to momentum final of body A plus momentum final of body B. So let's talk more about that. So from the previous page, we saw that momentum initial of body A plus momentum initial of body B is equals to momentum final of body A plus momentum final of body B. So I said this is what you call the law of conservation of linear momentum. It just says that the total linear momentum of an isolated system is conserved or it remains constant. That is the law of conservation of linear momentum. So irregardless of how many objects you are having that are in an isolated system that are colliding with each other, all we know is the total linear momentum initially will be equal to the total linear momentum final. Even if there are three objects, so we say momentum of body A plus initial momentum of body B plus initial momentum of body C will be equals to the momentum final of body A plus momentum final of body B plus momentum final of body C, irregardless of how many objects you are having that are involved in a collision. No matter how many objects are involved in a collision, all we know that the total linear momentum of that isolated system will be conserved. So it means that if we add all the momentums of these objects before the collision, so initially, like I explained, we're not talking about initially, we're talking about before collision. And we're not talking about the final, we're talking about after the collision. So the total linear momentum of that system that is isolated will always be constant or will always be conserved, right? So now, how are you going to apply this law of conservation of linear momentum? So we are going to have a couple of questions and I'm going to help you to solve this type of questions. So before us, we're having this question here. So we can see that this situation is before the collision. we can see that we are having body A with mass 1 kg, body B with mass 1.5 kg. So body A was moving to the right at 2 meters per second, and body B was moving to the left at 1.5 meters per second. Then after the collision, the masses are still the same. The velocity of this now of body A is unknown. So velocity of A is unknown now after the collision. But the velocity of body B is 1.2 meters per second to the right. So before attempting this question, since you know that momentum is a vector quantity, what we are going to do is we are going to choose the direction between the left and the right. We are going to choose which one do we prefer to keep it positive. So according to the way I feel right now, I just want to put my right to be positive. So it means that my left will be negative. So now let's get to find the solution of this. So we can write our formula. So the total linear momentum of an isolated system will always be conserved. So momentum initial will always be equal to momentum final. So what do we have? We are having mass velocity of body A initial plus mass velocity of body B initial is equals to mass velocity of body A final plus mass velocity of body B final. So our mass of body A is 1 kg and our velocity is going to the right, so it is positive, so we can just substitute 2 there. And our mass of body B there, it is 1.5 kg, and our velocity there, it is going to the left, so we said left is negative. So always remember the direction is very, very important here. So always remember, don't attempt any question before choosing the direction. Sometimes the directions are not as clear as left or right. Sometimes they can tell you towards the target or away from the target. So it means that you can pick towards your target as your positive and then away from the target as your negative, right? But either way, there will be a sort of direction. There will be a sense of direction there. So this will be negative 1.5 being equals to, and after the collision, you know that our mass still is 1 kg and the final velocity we don't know, plus the mass of that, which is still 1.5, and our velocity now it is going to the right, so that's 1.2 now. So this doing the calculation, this will be 2 and this will be negative 2.25 being equals to velocity final plus 1.8. So we can take this 1.8 this side, so it means that our final velocity can now become negative 2.05. So that's the final velocity. But before concluding that, you can see that this is saying negative, and already we have chosen our left to be negative. So it means that therefore the final velocity of body A is 2.05 meters per second left. So this is going to the left at that velocity. So that's how you can solve this type of questions. So don't forget that I said I will deal with more of these questions when you are dealing with lesson 4, when you are just focusing on exam papers, like the typical exam questions. But I feel like we can just do one more question, including the conservation of linear momentum, before I can go to elastic and inelastic collision. So let's get a second type of this question. So in this situation, they said a 1050 kg car has a velocity of 2.65 meters per second north. So it means that already we can choose our north as positive, right? So it means that our south will be negative. So the car hits a stationary track. So it means that this track was stationary, so it means that its initial velocity is 0. And so this is the initial velocity of the car. And the bumpers lock together. The velocity of the car track system. So now it means that after hitting this track, they locked together and they started to move as a system, as one object now. Immediately after the collision is 0.78 meters per second north, right? And they say calculate the mass of the track. So what we need right now is the mass of the track. So what do we do? So already we chose the direction north positive and south negative. So first we just write our formula. Initial will be equals to the total momentum final. So since before they were separated, they were a separate system, and then after the collision they are now acting as one. So it means that after the collision we can put them together as one. So it means that our momentum of the car initially plus the momentum of the truck initially is equals to the momentum of the car truck finally, because now they are a system. So this means that our mass of the car multiplied by the velocity initially of the car plus the mass of the truck multiplied by the velocity of the truck initially is equals to now the mass of the car plus the mass of the truck. So now they're a system, right? Multiplied by the velocity of the car and the truck. So they are a system. So now what do? We know that the mass of the car, it is 50 multiplied by the velocity, which was 2.65. So we chose our north as positive, so this is positive like that. So here the mass of the truck we don't know, but we know that the velocity initially was 0 because this was stationary. So it means that the velocity was 0. Because to the mass of the car plus, sorry, the mass of the car we know it, which is 1050, and the mass of the truck, which is unknown, but the final velocity after they're moving as a system, it is 0.78. So multiply by 0.78 like that. So it will mean that this multiplied by that will just give us 2782,5 plus the mass of the truck multiplied by 0, which will just give us 0, will be equals to 1050 plus the mass of the truck multiplied by 0.78. So since these are multiplying each other, it means that we can straightforward divide both sides by 0.78. So we can divide by 0.78, and since this is 0, 0 will just go right, divided by 0.78. So we can see that our 1050 plus mass of the truck will be equivalent to 3567.31. So this is a 6, right? So we can take the mass of the car that side, and our mass of the truck will be equivalent. So we can subtract 1050 that side, and we can have 2517.31 kg. So the questions can come in different formats and different ways, different styles, but always remember that the total linear momentum of an isolated system is conserved. So you can use that formula to try to track down where you are trying to find or what you are trying to calculate, right? Let's just move straight to elastic and inelastic collisions, right? Elastic and inelastic collisions. So sometimes when a collision occurs, we see that objects deform. So it means that they change their shape, they can deform, or sometimes they give off light. So sometimes they give off light. I'm sure you have noticed a situation where a collision is giving off light or gives off the sound. So they can also give off the sound. And at the same time, the system where the collision happened, it can heat up. So also it can heat up, right? So when all this happens, where after the collision, when you can see these signs, or when these are happening, when a collision is taking place, you just know straightforward that this kind of collision is inelastic. So what do we mean now by inelastic? It means that during the collision, the kinetic energy of the system was not conserved, right? So inelastic collision means that the kinetic energy of the system was not conserved. So it means that the total EK initial and the total EK, so the total EK final are not the same. So when all this happens after the collision, we know that the kinetic energy will never be conserved. So it means that this collision was inelastic. So it means that the kinetic energy was not conserved. So what about the situation where the kinetic energy is conserved now? So when the total EK initial is equal to the total EK final. So this now is regarded as elastic. So this is a elastic collision. So it means that no energy was lost during this collision. So it means that the total kinetic energy initial will be equal to the total kinetic energy after the collision. So don't forget that when we say initial and final, what do we mean? Initial we mean before the collision, and final we mean after the collision, right? So also one hint that can show you that this is an inelastic collision, also you can see something like this when objects lock together. So when objects lock together, it means that the collision was inelastic as well. Or when one object becomes embedded in another object, it means that the collision was inelastic. So now let's see two types of the questions that they can ask in this kind of situation of elastic and inelastic collision. So we are having this situation. They said before the collision, we are having body A there that is moving to the right at 4 meters per second, and we are having body B that is moving to the left at 3 meters per second. So body A is the mass of 0.3 kgs, and this one is having a mass of 0.5 kg. And after the collision, body A moves in the opposite direction, so it means that it moved to the left at 4.75 meters per second, like that. And the final velocity of body B, they didn't give us, so we have to calculate that. But they told us that the collision is elastic now. They said the collision is elastic, so it means that we must find the final velocity of body B now. So what do we do? So before attempting anything, we choose the direction. So we can say our right can be positive, so it means that our left will be negative. So we know that since they said the collision is elastic, we can say the total EK initial is equals to the total EK final. So now how do we calculate the kinetic energy? So it means that the kinetic energy, so EK of body A initial plus EK of body B initial will be equals to EK of body A final plus EK of body B final. So we can expand that. We know that kinetic energy is just half mv squared of body A plus half mv squared of body B will be equals to half mv squared of body A plus half mv squared of body B. So this will be half, and the mass of body A is 0.3, so 0.3, and the velocity there is 4 squared, it is moving to the right. And this, the same thing, half, the mass being 0.5, and the velocity there being 3, so that will be a negative 3 since it is going in the opposite direction. So because to half the mass of body A, still it is 0.3, and the final velocity being 4.75, but negative since it is going in the opposite direction, squared, plus half the mass is 0.5 and the velocity squared. Final, we are trying to find that. So we can punch everything in the calculator from the left side there. We got 4.65, and plugging this we get 3.38, and half multiplied by 0.5 is 0.25 v squared final. So we can take 3.38 that side, and we can get 3.38. So it means that this side we got 1.27 after taking this side being equals to 0.25 v squared final, and we can divide by 0.25 both sides. So this side becomes 5.08 being equals to v squared final. So the square root there. So it means that our final velocity, it is 2.25 meters per second. Since it is positive, it means that it is going to the right. So this is how we can find the velocity using elastic collision. So they told us that this was elastic collision, right? However, you know that if the collision is elastic, you can also use the law of conservation of linear momentum, right? So you can try it out using the law of conservation of linear momentum. This question you can also try it using that, right? Yes, so I think a lot of questions we will cover them when we are dealing with lesson 4, when we are dealing with typical exam questions, right? So also the link of the document that will be solving, I'm leaving it in the description of this video. If you haven't subscribed, please just rush to subscribe to our channel, and I'll keep on bringing you the best of the lessons. Until the next lesson, please stay blessed. I'll see you on the next one. Have a lovely